Perfect. All right, now I'm recording. All right. Yeah. So rational functions and their graphs. Sorry. I'm gonna remind you first what's a rational function, right? And then I'm gonna remind you two important notions: the notion of horizontal asymptote and vertical asymptote. So yeah. So let me just remind you first what's a rational function. So I mean, I know we discussed this last Wednesday, but I'm going to just remind you very quickly. So a function or a rational function. So a rational function f of x, that's a function of the form so it's a quotient of polynomials. So it's a form of the form p of x over q of x, right? Where p and q p of x and q of x are polynomials. So it's a quotient of polynomials, right? And then yeah, and then we discussed so of course the goal. So what we want to do in this section, so the goal of this section, of course, is to graph rational functions. Now, to graph rational functions, we need the notion of vertical asymptote and a horizontal asymptote. So let me just remind you now the horizontal asymptote and the vertical asymptote. So first, let me start with a vertical asymptote. Okay. So what's a vertical asymptote? Well, it's called vertical because it's a vertical line. Okay, so vertical asymptote, it's a vertical line first. Okay, so this is a vertical line. So it's a vertical line. So the equation of this vertical line is x equal to a, given by x equal to a. So it means that this vertical line is going to pass through the x equal to a. Okay, so x equal to a says that so if if x approaches a, okay, then the function f, the values of the function f, they're gonna approach infinity. Then f of x goes or approaches positive or negative infinity. Okay, so in other words, so the idea is the following. So you have so you're gonna have so let's say you want to graph f somewhere here. Let's say this is your x equal to a. This is your x equal to a, right? The horizontal axis, of course, that's your x-axis, right? This is your x-axis. So you have this x equal to a, and so your let's say this is here's your vertical asymptote. So it's a vertical line, x equal to a, right? And then so if this is a vertical asymptote for your graph, then what happens is the following. So the values of the function f, they're gonna approach infinity as x approach a. So you're approaching a, the x approaches a. So like the variable x is gonna be like in the neighborhood of a, like in this, as you can see in this green interval. It's not equal to a, right? You are in the neighborhood of a, and then the values of f or your graph is going to approach positive, either positive or negative infinity. So of course, this is supposed to be positive infinity. This is negative infinity. So the values of the function f, they're going to go to infinity. So you're going to have like, so you're going to approach your vertical asymptote, right? So as you can see, the values of the function f, they go up or down, of course. So we're going to go to positive or to negative infinity, right? But the thing, guys, is that, so this graph, the graph of f, so this is supposed to be your f of x, it doesn't intersect the vertical asymptote. So there is no intersection with the vertical asymptote. So here, as you can see, your vertical asymptote is going to be very close. Actually, the graph is going to be as close as you want from the vertical asymptote, but it doesn't intersect the vertical asymptote, right? So here's the same thing, right? So on the other side, you're going to have like, let's say, same thing. So it's going to be very close to this vertical asymptote as x approach a. So again, you are approaching the variable x approach a, right? You're approaching x equal to a, right? Here you can have something at negative infinity. So the graph is going to look like the following here. This is, let's say, f of x, right? And as I said, so there will be no intersection here, no intersection with the of f of x, or graph of f of x with the vertical asymptote. Okay, here's the same thing. There's no intersection, and that's because, guys, the thing is, f of a, it's undefined. Okay, so you have to keep in mind that f of a, so your f of a is actually undefined. So you're not allowed to intersect this vertical asymptote. That's because if you intersect the vertical asymptote, so let's say here's, again, this is your vertical asymptote. This is x equal to a, right? So if your graph intersect, if it touch the vertical asymptote, then f of a is gonna be well defined, right? So then f of a would be like, f of a would be equal to, so this is a, right? This is x equal to a, and so f of a would be some, some number. It's well defined. Let's say, for example, I don't know, let's say 100 here, right? Then f of a would be 100. So if you touch this vertical asymptote, then f of a would be well defined. The output y is well defined, right? So yeah, and that's actually how we find the vertical asymptote. So to find the vertical asymptote, just to remind you how to find the vertical asymptote. So your function f is given by, again, it's a rational function, so it's p of x over q. Okay, and so to find vertical asymptote, we need to solve denominator equal to 0. So we need to solve q of x equal to 0. So denominator equal to 0. In other words, you need to solve q of x equal to 0. Okay, and the values or the solutions of q of x equal to 0, they don't belong to the domain of f, right? Because that's where the denominator is going to be 0. And remember, guys, we're not allowed to divide by 0. So the values or the solutions of q of x equal to 0 or denominator equal to 0, they don't belong to the domain of f. So that's why f of a is undefined, right? So that's how we find the vertical asymptote. Now for the horizontal asymptote, and of course here for the vertical asymptote, you can have more than one vertical asymptote. You can have like 3, 4, or and so on, okay? Now for the horizontal asymptote, so let me remind you what's a horizontal asymptote. Again, so it's called horizontal because it's a horizontal line. So this is a horizontal line. So it's a horizontal line. It's a horizontal line. Okay, given by, let's say, so the equation of this horizontal line, let's say y equals to L, all right, says that. So for the horizontal asymptote, guys, we are interested in the behavior of the graph of f in the neighborhood of infinity. So so when or if, so if x approach positive or negative infinity. Okay, so you see here the difference between horizontal and vertical asymptote. The vertical asymptote, so in the vertical asymptote, your x, the value of x, approach this number a, right? So like here, I have, this is my a, x equal to a, and I'm trying to approach a, either from the left or from the right, right? So I'm approaching this number a, okay? For the horizontal asymptote, x is going to approach infinity. So x is going to be like in the neighborhood of infinity. So like in the graph, so this is your positive, negative infinity. Of course, this is your x-axis. So your x, the value of x, is going to approach either positive or negative infinity. So it's going to, x is going to get very large, right? So your x is going to be like somewhere like in a neighborhood. Here's your x, right? So x here approach infinity or positive infinity, okay? Because you're really close to positive infinity, right? You're in the neighborhood of positive infinity. Or of course you can be like in the neighborhood of negative infinity. Okay, so if x approach positive or negative infinity, so your x like in this green interval, close to positive or negative, then, so what happens to the value of y or of f of x? Then f of x, the values of the function f, they're gonna approach this number L. Okay, so it's a horizontal line. So you're gonna have like, so let's say this is L. Y is equal to L would be this line. This is where y is equal to L. So this is where y is equal to L, right? Because again, this is the vertical axis. That's supposed to be your y-axis. So when I say y equals to L, it means the line which passes through the, you know, this number L here on the y-axis, right here. Now, so what I'm saying here is that, so if x is in the neighborhood of positive or negative infinity, then the function f, or the output, is going to be close to L. It's going to approach L. So my graph, the graph of f, is going to approach this line L. Okay, so my graph is going to approach, is going to get as close as I want from L, or from this line L. So here's my graph. So as you can see, it's going to be very close, as close as you want from the line L. But of course, again, it won't intersect this line L. So on the other side, of course, you can have the same thing. So your graph is going to be very close to this line L. Right, this is, again, this is your f of x. And again, so here there's no intersection. So there's no intersection. Right now, so that's for the idea. So that's what I mean by horizontal asymptote. Now, how do we find the horizontal asymptote? So I'm gonna just remind you again. So what we said Wednesday last week. So to find the horizontal asymptote. Now for the horizontal asymptote, you can have no more than one, okay? It's either 1 or 0. You can have no more than one horizontal asymptote. Now, to find the horizontal asymptote, the idea is to compare, you need to compare the degrees of P of X and Q of X. Again, degree, what I mean by degree, guys, is that will be the highest power of X, right? So the degree, that's the highest power of X. Okay. And so we're gonna have like 3 different cases when you compare, you know, the highest power of X in the top and the highest power of X in the bottom. So we're gonna have like three cases. So the first case is when, for example, the highest power of X in the top is larger. So case 1, for example, so degree of P, degree of the highest power of X in the top, let's say, is larger than the degree of the highest power of X in the bottom. So that's the degree of Q, right? Again, f of X, it's supposed to be P over Q. All right, so in this case, if the degree of the top is larger than the degree of the bottom, then there is no there's no horizontal asymptote. Okay. The HA, guys, of course, stands for horizontal asymptote, right? Now, the case number 2, if the degree of the case number 2, if the degree of P is less, so the degree of the highest power of X in the top is less than the highest power of X in the denominator of Q, then Y equals to 0 is going to be is the horizontal asymptote. Is the horizontal asymptote. Okay, and finally, last case, this is when P and Q have the same degree. So the highest power of X in the top is the same as the highest power of X in the bottom. So degree of P is equal to the degree of Q. And then in this case, the horizontal asymptote is going to be equal to the leading. So Y is equal to the leading coefficient of P. The leading coefficient, that's the number in front of the highest power of X of P over the leading coefficient of Q. Of Q. So this line is going to be is the horizontal asymptote. So as you can see, you can have no more than one horizontal asymptote, right? So in the first case, there is no horizontal asymptote. Then in the case 2 and 3, of course, there's only one horizontal asymptote. All right. Anyway, so we discussed this Wednesday. So I'm trying to remind you what we did last Wednesday, last week. Now I'm going to use, of course, all these informations to graph rational functions. So today I'm going to show you how to graph rational functions. So how to graph. So I'm going to go with an example. Again, graphing rational functions, it's kind of tricky. It's not. I mean, it's not easy in general. So we're gonna do a lot of examples, right? So how do we graph rational functions? All right. So I'm gonna go with the first example. So example 1, right? And I'm gonna take, so f of x, so f of x is equal to, let's say f of x is x minus or x minus 4 times x plus 1 over x minus 3 times x plus 2. All right. So what are we going to do first? Well, before the steps, let me just say here one word about this function f. So this is a rational function because, of course, the top, this is your, so supposed to be your p. So this is your p of x, and here's your q. Okay, so just want to remark about p and q. Actually, p and q, the degree of p and q, just remark here. So for example, for p of x, well, as I said, it's at the top. So this is just the x minus 4 times x plus 1, right? But in other words, this is actually, I mean, if we distribute, you know, if you multiply your x by x by 1, then 4 by x, and then 4 by, or negative 4 by x, and then negative 4 by 1. So your p of x actually, it's x squared plus 1 times x minus 4 times x, and then minus 4 times plus 1. So that's negative 4. Right. So as you can see here, the degree of p, the highest power of x, so the degree of p, it's not 1. So as you can see, it's actually 2. Right. So the degree of p, so degree of p, again, this is the highest power of x. Highest power of x. It's not 1. It's actually 2. Right. That's the highest power of x. It's not 1. Same thing, of course, for q. The degree of q is going to be also 2. All right. Now, how do you graph this function f? So first, we need to find. So step 1 would be to find the vertical asymptote. So we need to find the vertical asymptote. Right. So in this example, and that's actually why I wrote Q as a product of factors, because so if you have like a product of factors, so to find the vertical asymptote, of course, you need to solve the bottom equal to 0 or the denominator. Q equal to 0, right? So in this case, it's we need to solve x minus d times x plus 2, right? Equal to 0. And, you know, so again, that's why I wrote Q as a product of factors, because if your Q is a product of factors equal to 0, you know, this is your first factor times, so this is multiplication, right? And this would be your second factor equal to 0, right? So then one of the factors is 0. So then, you know, you don't have to apply like the quadratic formula or anything, right? Or you don't have to factorize. You can just say, well, it's either the first factor is 0, the x minus d is 0, or the x plus 2 is 0. Right? So then x minus d is 0, of course, then x is equal to 3. And x plus 2 is 0, then your x is negative 2. Right, so we got 2 vertical asymptote. All right, so the answer here would be, so we have, so the vertical asymptote are so it's x equal to negative 2 and x equal to positive 3. Okay. You know, guys, I mean, the goal of this exercise for this example is to graph. I'm going to show you how to graph, you know, the rational function. So the goal here is not really to, you know, to factor or factorize your p or q or etc. Right? So, I mean, in the homework or, you know, in the test, you know, if you have like an exercise about the graphing rational functions, most of the time you're going to have like the top or the bottom would be just a product of factors. Okay, you don't have really to apply or to factorize, you know, your polynomial to solve, you know, to solve your equation equal to 0, right? Anyway, so that's for the first step. Second step, we need to find the horizontal asymptote. Okay. And so to find the horizontal asymptote, we said we compare degrees of P and Q. Right, the highest power of P and highest power with the highest power of X and Q. So I mean, P is, we said P is, let me write it again here. So we said P is X minus 4 times this X plus 1. And then we said this is, you know, plus 1, sorry. And then we said this is plus X minus 4X, etc. So we said the degree of P is 2. Is equal to 2. That's because, again, this is the highest power of X. Same thing for Q. So Q is, where is it? X minus 3 times X plus 2 times X plus 2. So then again, you distribute. So you have like X squared plus 2X, you know, minus dx minus 6, right? And then, so then the same thing, the degree is the same. Degree of Q is going to be also the highest power of X is going to be also 2. Right, so this is 2, so we're going to have 2 again here. All right, so then degrees are equal, and so we are in the third case. So degrees P and Q are equal. Right, they are equal, and in the case number 3. So this would be the case number 3. Right, now if you check what's the case number 3, let me go up a little bit. So right here, so the degree of P is the same as the degree of Q. So then the horizontal asymptote is going to be y equals to the ratio of the leading coefficients. So we need to take the leading coefficient of P over the leading coefficient of Q. Right, so then the answer, so the horizontal asymptote is y equal to, so leading coefficient of P over the leading coefficient of Q. Now, what's the leading coefficient of P of Q? So for P, the leading coefficient, that's again the number or the coefficient in front of the highest power of X. So this is, so you have X squared, right? So this is like 1 times X squared, right? So in front of X squared, we have 1. So that will be 1 here over leading coefficient of Q. So it's also X squared. So and in front of the X squared, that will be 1, right? So it's 1 over 1. And so the answer, the horizontal asymptote is going to be y equal to 1. Okay.
Excuse me.
Yes, please. Yeah.
You kind of lost me after comparing the degrees of the P and the Q.
So, I mean, that's what we do to find the horizontal asymptote. you need to compare the degrees of P and Q. So you have to determine whether the degree of P is larger or equal or less to the degree of Q. And what we are saying here, so that you agree with me that the degree of P is 2, right? The highest power of X in P is 2, right?
I agree.
And then the same for Q, it's also 2, right? So then they are equal. They have the same degree. P and Q, they have the same degree, right? So if they have the same degree, so then remember we have like 3 cases when you compare the degrees of P and Q. So in the case 3, number 3, this is when the degree of P is equal to the degree of Q. And in this case, what we are saying is that the horizontal asymptote is going to be given by this. Okay. So for example, if your degree of P is less, then that will be the second case. If the degree of P is less than the second case, and then so this is y equal to 0 would be the answer. If the degree of P is larger than the degree of Q, then there will be no horizontal asymptote. Right, so we are in the third case because P and Q, they have the same degree, which is 2. So then the answer should be this. Y would be the leading coefficient of P over the leading coefficient of Q. Make sense now?
Okay, yes, thank you, yes.
Sure. So yeah, and this is why I wrote here leading coefficient of P over leading coefficient of Q. And yeah, leading coefficient of P, as I said, that will be the number in front of the X square. So that's 1, and Q the same, it's also 1. So that's why I got 1. It's 1 over 1, right? All right, so we got the horizontal or the vertical asymptote. This is the horizontal asymptote. Then next we're gonna need and the y-intercept. The y-intercept in the rational graphing rational functions, they are really, really important. We're gonna see in a couple of minutes. They are kind of really important. So step 3, we're gonna need the x-intercept. Okay. So just to remind you, the x-intercept. So what we do in general to find the x-intercept, we need to solve the function f equal to 0, right? So that's what we do in general to find the x-intercept. So let me just remind you here, to find the x-intercept, we are supposed to solve. We are supposed to solve f of x, the function f of x equal to 0, right? But the thing is, our function f, I mean, in rational function, our function f is actually quotient, right? F of x is supposed to be p over q, right? So this is like p over q. P of x equal to over q of x equal to 0. So that's what we are supposed to solve. But the thing, guys, so if you have a fraction, I mean, if you have a fraction equal to 0, you know, the only way to get 0 when you have a fraction is that the top is 0. Okay, if you have like 0 over 1, right, that will be 0. 0 over any non-zero number, you know, 0 over 100, that will be 0. So the only way to get 0 if you have a fraction, you know, is that your numerator is 0. Is that the top is 0. That's the only way to get 0 if you have a fraction. You need the top to be 0. You don't really care about the bottom. Of course, you are not allowed to divide by 0, but you don't really care about the denominator when you solve p over q equal to 0. So so what I'm saying is to solve p of x over q of x equal to 0, all you have to do is to solve p of x equal to 0. Because that's the only way to get 0. If the top is 0, then the fraction is going to be 0. Right? So then what we need to do is to solve p of x equal to 0. Right? In other words, we have to solve the top equal to 0. All right. So don't get confused, guys, because to find the y, to find the vertical asymptote, we had to solve the bottom, the denominator equal to 0, right? Now for the x-intercept, you have to solve the numerator. You have to solve the top equal to 0. Okay, so so x-intercept are different from the vertical asymptote. Vertical asymptote. So the vertical asymptote. Where is it? Yeah. So the vertical asymptote, as you can see, we solve the bottom equal to 0. Now for the x-intercept, we solve the top equal to 0. Okay. I mean, that's always the case. Whenever you have a rational function and you want to find the x-intercept, just solve the top equal to 0. Now, what's the top, or what's p? What's the numerator? Well, it's this. Where's p? Well, here's p, right? This the top here would be the the x minus 4 times x plus 1. So we need to solve x minus 4 times x plus 1 equal to 0. All right, and again, guys, because this is a product of factors, so you don't have to factorize your polynomial. So you have, this is your first factor times, and this would be your second factor. So because it's a product equal to 0, then either the first factor is 0, so either the x minus 4 is 0, or the x plus 1 is 0. So x minus 4 is 0, then x is positive 4. And then x plus 1 is 0, then x is negative 1. All right, so we got two x-intercepts. So x-intercepts are, so first we have 4. So remember, guys, for the notation of x-intercept, so we use the points notation. So it's 4, 0, 4, 0, right? Because this is supposed to be your x coordinate, right? And this is supposed to be your y coordinate. And the other point is negative 1, 0. Okay. So that's your x-intercept, and we are almost done. Then we're gonna need the y-intercept. So step 4, it's we need to find the y-intercept. So to find the y-intercept, all you have to do is just to plug the 0 in the function f. So you have to evaluate f of 0. F of 0. Right? So what's f of 0? Just all you have to do is just to replace x by 0. Well, let me write again here, f of x, just to remind you what's f of x. So it's x minus 4 times x plus 1 over, it's, I think, x minus 3 times x plus 2. All right, so just replace x with 0. So this is 0 minus 4 times. So be careful, guys, here, because this is a kind of like a common mistake. So between x minus 4 and x plus 1, it's not addition, it's not subtraction. This is a multiplication, right? The dot here, it's a multiplication. Yeah, so it's 0 minus 4 times 0 plus 1 over 0 minus 3 times 0 plus 2. All right, so 0 minus 4, that's negative 4 times, right? It's not plus or it's not minus, it's times. times 1, positive 1, right, over negative phi times the positive 2. Okay. So yeah, then the answer would be, let's see, so f of 0, the top, that's negative 4 times 1, so that'll be negative 4, and the denominator, it's negative 3 times positive 2, so negative times positive, of course, is negative, that will be negative 6. Negative over negative, that will be positive, so this is positive, right? And then we can reduce this fraction if you divide, I mean, both 4 and 6 are divisible by 2. So we can divide both of them by 2, right? So here over 2. So that will be 2/3. Right, so yeah, so then the answer, y-intercept is, again, for the y, as you know, like we did for the x-intercept, we're gonna use the points notation, right? So y-intercept is 0, 2/3. All right. Okay, so now we got everything we need to graph our rational function. Okay, so now last step, we can graph our function f. So now let's graph f of x, which is, by the way, it's x minus 4, x plus 1 over x minus 3 times x plus 2. Right? So I'm gonna just remind you here. So for vertical asymptote, vertical asymptote, we got x equal to positive phi and x equal to negative phi. Horizontal asymptote, we got y equals to 1. X-intercept, we got -1, 0, and 4, 0. And finally, for the y-intercept, we got the 0, 2/3. This is 0, 2/3. All right, so now let me show you how to use these informations to graph f. As I said, sometimes it's tricky to graph those rational functions. So let's see. So of course, this is negative, positive, infinity. This is positive, negative. All right, and then I guess we're gonna need, so this is positive 1. We're gonna need -1 and 4. This is -1. This is positive 1, let's say 2, 3, and then let's say this is 4. And then I'm gonna need the 2/3. So here somewhere, I'm gonna have the 2/3. All right. Yes. Okay. Perfect. All right. So what I'm gonna do first, I'm gonna just draw the vertical asymptote and the horizontal asymptote. So let me draw the vertical asymptote. So vertical asymptote. First, we have this. Well, when you graph a function, guys, you always start from the left. You go from left to right. Okay, that's like what we do in general. But first, let me draw the vertical asymptote. So we have x equal to -2. I forgot the -2 actually. Oops. So here is my -2, and I need the x equal to 3, of course. All right, so this is so this is 2, this is 3, and here's 4. All right, so we have x equal to -2. That's my first vertical asymptote. So here's my x equal to -2, right? Then x equal to positive phi, my second vertical asymptote. It's x equal to positive phi. Okay, so of course it's supposed to be a straight line, but okay, this is a straight line, of course. Okay. Okay, that's for vertical asymptote. Now for the horizontal asymptote, we got y equals to 1. So here's my horizontal asymptote, y equals to 1. This is 1, right? I mean, of course, the vertical axis, that's my y-axis. So this is y equals to 1, right? And then there is x-intercept. We have negative 1, 0. We got 4, 0. And then there is a 0, 2/3. Right? So this is a y-intercept. Okay. All right, so let's graph this function f. So we are supposed to start from the left, okay? In the left, of course, you have your negative infinity and you have your horizontal asymptote, the green line. That's the horizontal asymptote. And by definition of horizontal asymptote, right, your graph is supposed to be as close as you want from the horizontal asymptote, right? So your graph is supposed to be very close to this horizontal asymptote, right? Of course, your graph can be like above this. It's either below the horizontal asymptote or above the horizontal asymptote. Right? But of course, you need to keep in mind, guys. So we have to determine which one is going to be the graph of f. I mean, the graph of f cannot be, at the same time above and below the horizontal asymptote, because otherwise it's not a function, right? If you use a vertical line test, if you take this line here, you're going to intersect, this graph like in 2 points. So that's not a function. So we have to decide either the top or the bottom is going to belong to the graph of f, right? So the graph of f is going to be either below the horizontal asymptote, right, or above the horizontal asymptote. It cannot be both, right? Otherwise, it's not a function. All right. So how do we decide which one is going to pick, the one above or the one below? Well, we don't know yet. Let's wait. Now, next, next, as you can see, again, I'm going from left to right. So next, there is this vertical asymptote, right? There is this vertical asymptote. And again, by definition, your graph is going to be as close as you want from this vertical asymptote at infinity, of course. So here at infinity, your graph is going to be as close as you want from this vertical asymptote. But of course, it can be, the graph of f can be like in the top or all the way down here. All right. So again, we have like two options. So, and we have to decide which one is going to be the graph of f. But the thing, guys, is that, so we have like, basically we have two options here. Either we can start above the horizontal asymptote and go all the way up, right? Or we can start below the horizontal asymptote and then go all the way down. And again, that's because here at infinity, you are not supposed to cross the horizontal asymptote, right? So we have like here two options. There's this first option here, and there's this second option, right? So we have to decide which one is actually the graph of f. It cannot be both, right? Because otherwise, it's not a function. Well, to decide which one, the thing is, if you take the one below the horizontal asymptote, right, you're gonna cross the x-axis, right? At this point, you're gonna cross the x-axis. And if you cross the x-axis, it means we have an x-intercept there, right? But there is no x-intercept. There's no x-intercept there, right? That my x-intercept, like it's at -1, right? It's not there. There's no x-intercept there, right? There's no x-intercept in this when you are close to a negative infinity, right? So what we are saying here is that because there is no x-intercept, like when you are close to negative infinity, so then you cannot really go all the way down here. You cannot start from below the horizontal asymptote. So again, because if you start from below the horizontal asymptote, you have to go all the way down. That's because you are not supposed to cross the horizontal asymptote. But if you go all the way down, you're gonna cross the x-axis. It means you're gonna have an x-intercept, but you don't have an x-intercept there. So the graph of f is gonna be above the horizontal asymptote, not below the horizontal asymptote, right? So the graph of f is gonna be this one here. The one above the horizontal asymptote. Right, so the graph of f is going to be this one here. This is actually your f of x. And this is like the first part of the function, of course. This is f of x. Right, so the first, what I'm saying here is that the first part of the function of the graph of f is going to be above this horizontal asymptote, right? Next, so again here, I'm not supposed to intersect the vertical asymptote, right? Here, okay, there's no intersection with the vertical asymptote. All right, next, the second part of the graph, so just right after -2, and because x equal to -2 is a vertical asymptote, so we have like, again, we have like two options here. Either we're gonna start from the top right here, close to this vertical asymptote, or we can start from the bottom here, right? Because again, this x equal to -2 is supposed to be, you know, my vertical asymptote. So again, guys, we have to decide which one is going to be the graph of f, because again, if you use a vertical line test, you know, you're going to cross 2 times the graph. So that's not a function. So we have to decide either. So we have like two options here. There's this first option here, or here, down here, there's this second option. Okay. So which one is going to be the graph? Well, let's see what happens with the first. So if you would continue with the one in the top. So then next thing we have is there's this x-intercept at -1, right? So I'm supposed to go through this -1, right? And then I have to join this y-intercept, the 2/3, right? Now, do you see any problem with this, guys? You see, you go to -1, and then you're supposed to join the 2/3, but then there's a problem because, as you can see here, you're going to cross again the x-axis. So it means that you're going to have an x-intercept there, but there is no x-intercept, you know, between this -1 and 2/3. So here, there is no x-intercept. Okay. So after -1, between -1 and 2/3, you're not supposed to cross again this x-axis. So because of that, we need to start the graph from the bottom, not from the top. So this is not the graph of f. It cannot be the graph of f. Okay, so we need to go. We need to start from the second, from the bottom. So the second option here would be the right one, and you will see there will be no problem with this, because you know you go from negative from the bottom to all the way up to -1, right? And then you can go to 2/3. All right. Now after 2/3, what do we have? Well, there's this vertical asymptote at +3. So again, it means we're going to have like two options, either the first one here in the top, or second option here in the bottom here, right? So if you go down, you know, to the second option, then as you can see, there will be a problem, because it means you're gonna cross the x-axis, but there's no intercept there. There's no x-intercept there, right? So we are not supposed to you're not supposed to cross the x-axis here, right? Because there's no x-intercept there. So we have to go all the way up. So we have to go, so the first option would be the right one. So here, we cannot go down because there's no x-intercept. We're not supposed to cross the x-axis. So we need to go up. So we need to go up here. Okay, so that would be like the second part of the function or the graph, right? This is my function f. So this is the second part of the graph. It's the between the two, between the two vertical asymptotes. All right, now the last part of the graph, the third part after the second vertical asymptote, right? Well, again, we're gonna have like two options, one here in the top, one here in the top, a second here in the bottom. Oops, what happened? Sorry about that, guys. Yeah, so one in the top and one here down here, right? This is my second option right here. Okay. And of course, again, we need to decide which one is the right one. So, all right, let's see what happens next. Well, there's this x-intercept at 4, right? And then there's, of course, again, my horizontal asymptote. So horizontal asymptote here at infinity, of course. So the graph is going to be above or below the horizontal asymptote, right? And so if you pick the first option, so it means that you're going to go down here, right? And again, guys, at infinity, you're not supposed to cross this horizontal asymptote. So, but there's a problem with this first option because there's an x-intercept at 4, right? So the idea is, of course, would be that the second option would be the right one because you can cross the x-axis at 4, and then, you can approach your horizontal asymptote. So, so here, because there's an x-intercept, we need to start from the bottom. Here, from the bottom, join the 4, and then we can go to the approach our horizontal asymptote. Okay, so that'll be the third part of the graph, f of x. So yeah, as you can see, guys, I mean, the graph of f in general, like, you're gonna have like, let's say here, like we have like 3 different parts of the graph, and each time when we have like vertical or horizontal asymptote, you're gonna have like 2 different options, and you have to determine which one is the right one. Okay. And that's like kind of why it's this graphing of rational functions kind of tricky, because but you need to analyze like the situation, right? You see, if you have an x-intercept, I mean, that's why here x-intercept are very useful, right? So we can decide whether you can cross the x-axis or not. Okay. All right. So yeah, that would be the graph of f of x. Is there any question, guys? I mean, of course, this is like first example. It's kind of scary, but we're gonna do more examples, of course. So I'm gonna do another example, and then I'll give you a couple of functions, rational functions to graph. All right. So let's say this is our first example. So let's do another example. Example number 2. All right, so the example number 2, we're gonna go with so again, f of x. So let's say your f of x is equal to 2x. Let's see here, 2x minus 1 times x plus 1 over x minus 2 times x plus 2. All right. So again, the same steps. Step 1. So we need to find the vertical asymptote. Right. So vertical asymptote as we said, just solve denominator equal to 0. So that's the x minus 2 times x plus 2 equal to 0. So that's, sorry, so that's x. So either x minus 2 is 0, or the x plus 2 is 0. Okay, so then this is x equal to positive 2, or x is equal to negative 2. Okay. And so then the answer, so vertical asymptote are x equal to 2, or, and sorry, and x equal to negative 2. Okay. So that's for the vertical asymptote. Next, we need to find the horizontal asymptote. Find the horizontal asymptote. To find the horizontal asymptote, we compare degrees of P and Q. Of P and Q. Again, here, this is very similar to the previous example. I mean, P would be like 2x squared plus 2x minus 1. Q would be x minus 2 times x plus 2. So that's x squared plus 2x, minus 2x, and then minus 4. So this is, again, similar to the previous example. So P and Q, they have the same degree, both. So they have degree equal to 2. So the degree is equal. So degree of P is equal to the degree of Q. Degree of Q, and that will be equal to 2. Right now, this part is different from the previous example because so when you have the same degree, of course, the horizontal asymptote is y equal to, and then we take the ratio of the leading coefficient. Now, the leading coefficient of P, it's actually equal to 2, right? This is 2x squared, right? This is 2, right? 2x squared. So in the top here, that's supposed to be 2. Okay, so 2 over, right? Now the leading coefficient of Q, the number in front of the highest power of x in Q, it's just 1, right? It's 1 here. So it's 2 over 1, right? So then the answer is 2. Right, so the horizontal asymptote is y equals to 2. Okay. Again, leading coefficient of P over leading coefficient of Q. Okay, so we got the horizontal vertical asymptote. Now the x-intercept. So yeah. So yeah, step 3, the x-intercept. And as I said, for the x-intercept, all you have to do is just to solve the top equal to 0. Okay. Vertical asymptote, that'll be the bottom equal to 0. X-intercept, it's the top equal to 0. All right, so what's the top? The top, of course, that's a P of x. That's the 2x, minus 1 times x plus 1. So we need to solve this equal to 0, right? So again, it's a product. So either the first factor is 0. So either the 2x minus 1 is 0, or the x plus 1 is 0. So 2x minus 1 is 0. Then x is would be 2x would be 1. You divide by 2. So then x would be 1/2. Right, and the x plus 1 is 0. Then x, of course, would be negative 1. Right, so then Then the solutions, the x-intercepts. So the answer here, x-intercepts are, so we have the half and the -1. And finally, for the y-intercept, so step 4. So the y-intercept, just evaluate f of 0. All right, so let me write down first f of x. So f of x, we said, you know, my original function is 2x minus 1 times x plus 1 over the x minus 2, x plus 2. That's my function f, right? So now the y-intercept, just replace x with 0, plug in 0 in the function f. So that's 2 times 0 minus 1 times 0 plus 1 over 0 minus 2 times 0 plus 2. Right? So be careful, guys, with PEMDAS rule, right? So, I mean, this 2 times 0 minus 1. So first multiplication, right? We multiply the 0 by 2, and then we subtract 1, right? So PEMDAS rule, just be careful with that. So then your f of 0 would be 0 minus 1. That's -1 times, it's not a plus, it's not a subtraction, it's times. I mean, it's a multiplication, right? Times +1 over -2 times +2. So that's -1 in the top, and then -4, right, in the denominator. So that's negative over negative, of course, that's positive. So that's 1/4. So this is 1/4. So y-intercept it's just 0.1/4. All right, now we can graph the function f. Okay, let's graph this function f, and I'm gonna remind you, of course. So f it's this 2x minus 1, x plus 1 over this x minus 2 times x plus 2. And just to remind you what we have. So for the vertical asymptote, we said, so we have x +2 and x is -2. That's for the vertical asymptote. For -2, all right. Then for the horizontal asymptote, we said it's y equals to +2. X-intercept, we just compute the x-intercept. So we said it's half and -1. And then finally for the y-intercept, we said it's 1/4. All right. So let's graph our function f. So of course this is positive, negative infinity, positive, negative infinity. We're gonna need, of course, the vertical asymptote. So we need +2 and -2. So this is +1, +2, -1, -2. So x-intercept, we're gonna need like 1/2. So here's 1/2. We're gonna need -1. I have already the -1. And for the y-intercept, I'm gonna need the 1/4. So 1/4. I mean, let's say this is 1. Oh, sorry, I forgot also for the horizontal asymptote, we need 2. So let's say this is 2, this is 1, and somewhere here that will be 1/4. This is my 1/4 right here. All right, so let me draw the vertical asymptote first. That's the +2, x equal to +2, x equal to -2. That's my vertical asymptote. Again, it's vertical, so it's a vertical line, right, passing through the x equal to 2 and x equal to -2. Now for the horizontal asymptote, it's y equals to 2. So horizontal, of course, means that it's a horizontal line, right? So the horizontal asymptote, y equals to 2. So here's y equals to 2. So here is my horizontal asymptote. Now we need the x-intercept, so we have half. So here's my half, and then there's a -1. Y-intercept, this is 1/4 right here, okay? And yeah, and that's it. All right, so as I said, you start from the left, from -infinity. You are at -infinity. Your x is close to -infinity, right? And of course, on the left, at -infinity, you have your horizontal asymptote, and you're at -infinity, your graph is supposed to be as close as you want from your horizontal asymptote. So again, we're going to have two options. So either the graph is going to be above the horizontal asymptote or below the horizontal asymptote, right? Again, so we have two options, right? This is like first option. This is the second option. Now, next, as you can see, guys, so next thing we have is this, the vertical asymptote, this blue line, right? There's this blue line. And when you approach your vertical asymptote, your graph is supposed to be as close as you want from the vertical asymptote. So again, we're going to have two options. So this is, first option would be this one here. This is another option here. And, or of course, your graph can be like in the bottom here, close to your vertical asymptote. So that's another option. Now, if you, so the graph, basically, what we are saying here is that the graph of f can be like above the horizontal asymptote. So it can be this one here, or it can be below the horizontal asymptote. So you can go all the way down here, right? So this is like your two options. So any guess which option is the right one? The one below or the above the horizontal asymptote?
The one on top.
Yes, absolutely. And that's because, so if you go down, I mean, if your graph is below the horizontal asymptote, there's one problem here, guys, because you see in this region here, there's no x-intercept, right? So you're not supposed to cross the x-axis, right? Like here, there's no x-intercept, so there's no way to cross the x-axis. So you have to go up, right? So yeah, thank you. So this is, so the right graph would be the one above the horizontal asymptote. So this is supposed to be my x-axis, of course, here. So we're gonna go up, right? And I'm gonna just erase this. All right. So this is the first part of the graph, okay? So we are not done yet, right? This is just on the left side of your first vertical asymptote, right? On the left of -2. Next, so what happens between the two vertical asymptotes, between the two blue lines, right? That's like the second part of my graph. So so what happens between the two vertical asymptotes? Well, again, you start, you're gonna be close to your vertical asymptote. So again, we're gonna have two options, one here in the top. This is my first option, and one here in the bottom, second option. All right. Now, if you start from the top, and then you're supposed to go, so next thing is this x-intercept at -1, right? And then you're supposed to cross again the x-axis and join the 1/4. That's your y-intercept. But again, here we're gonna have a problem because, well, as you can see, there is no x-intercept here, right? You're not supposed to cross your x-axis like between the -1 and the 1/4. There's no x-intercept there. Okay. So the right thing to do here, guys, is start from the bottom. So you need to start from the bottom. So I need to erase this first. All right. So now, if you start from the bottom, you'll see that there'll be no problem. You can join your first x-intercept. This is my next x-intercept. You can go to your y-intercept, 1/4, and then you can join your the one half, your x-intercept, and then of course you're gonna have again the second vertical asymptote at x equal to 2. And again, because x equal to 2, it's a vertical asymptote, you're supposed to have like two options, either here in the bottom or the graph can be here in the top. But then after one half, guys, I mean, if you decide to go up, well, then there will be a problem because you're going to cross again the x-axis, right? And so it means you need an x-intercept there, but there's no x-intercept after one half. So you have to go all the way down, right? So then, so the right thing to do is to go all the way down from half to the all the way down to this negative infinity here. So that will be the second part of the graph. Okay. And that's the graph like between the two vertical asymptotes. So this is my f of x. Now, we are not done yet because there is a third part of the graph after the second vertical asymptote, after the second blue line. And again, because it's a vertical asymptote, you're going to have two options here. This is first option in the top or here in the bottom. But then after that, there's no x-intercept. There's just the horizontal asymptote at infinity here, right? And again, you're going to have two options, either above or below the horizontal asymptote. But then if you start from the bottom and you go up to your close to your horizontal asymptote, then again, you need to cross the x-axis, but there's no x-intercept after, after the one half, you're done with the x-intercept. So you're not supposed to cross the x-axis there. So the right thing to do, of course, is to start from the top here and just go to your horizontal asymptote. So so that would be the third part of the graph. So that's my f of x here. Right. So as you can see, guys, I mean, the problem with this horizontal vertical asymptote is like you're gonna have like two options, right? And then you have to determine which option is the right one. And that depends actually, in most of the cases, depends on the x-intercept, if you do have an x-intercept or not. Okay. Any question, guys? Well, so you know what? Let's do a couple of exercises, right? So I'm gonna give you some time to graph, to try at least to graph one rational function. So here's an exercise. All right. So so here's my function f. So f of x is equal to so we have, let's say, x here times x minus 2, and then there's this x minus 3, right? And then where is it? Yeah, x plus 3. All right. You know what? We can take probably here. Let's take 2x here. Okay, 2x times x minus 2. All right. So first, so 1, 2, 3, 4, 5. So we need to find the vertical asymptote, then find the horizontal asymptote, then find the x-intercepts, find the y-intercept, and then of course graph the function f. All right, so I'm going to give you some time to think about this function f, guys. So again, to remind you guys, we're gonna meet in person this Wednesday. So they fixed the problem with the heating. So yeah, so I will see you in person this Wednesday.
Professor,
Yes, please.
um, vertical asymptote will be x equal 3 and x equal -3.
Yeah, for the vertical asymptote, yes.
The horizontal asymptote will be 2.
Yep. Yes.
The x-intercept will be 2 multiplied 2.
No. So we're gonna have 2 and 0. Yep.
Then y-intercept will be 0.
Yeah, it's gonna be just 0. Yeah. Yeah. I mean, rational functions, guys. I mean, in general, they're really hard to graph. I mean, this is not easy. Graphing rational functions is not easy. In general, I mean, it's not an easy task. Yeah, I mean, finding the vertical asymptote, this is, as I said, this is just to solve, in general, you need to solve the denominator, right? Equal to 0. This is for the horizontal asymptote. You have to compare degrees of P and Q.
Professor,
Yes, please.
is the vertical asymptote for this problem x equals +3 and x equal -3?
Yeah, absolutely. Yeah, correct. Absolutely. Yeah. Yeah, absolutely. Yeah, yeah, that's the correct answer. So yeah, you solve the denominator equal to 0 to find the vertical asymptote, horizontal asymptote, compare degrees of P and Q. So of course, my advice for you guys, like in the test or in the final, just write like you can write down like an example in your formula sheet, or just write down, well, you have to solve denominator equal to 0, etc. Right? For the x-intercept, it's different from the vertical asymptote. Okay, so x-intercept, that's where you solve the numerator equal to 0. Right? Y-intercept, just we plug 0 in the function f. And then, of course, the tricky part is to graph f.
Professor,
Yeah, please.
for the x-intercept, right?
Yeah, yeah.
Is it 0 and 2?
Yep, yeah, it's 0 and 2. Yeah.
Okay.
So probably next time we'll have more examples, guys, because I mean, in my two examples and also this exercise, like the degree of P and Q is the same, right? Like it's a horizontal asymptote here, you take the leading coefficient of P over leading coefficient of Q, right? But I guess we need to, you know, to do at least one example where the degree of P is, let's say, less or larger than Q, right? So yeah, probably next time in Wednesday, I'm gonna do one or two more examples. And also I can check if you guys have a trouble with this graphing this rational functions, and then yeah, and then we can move to the next section. But yeah, so on Wednesday we're gonna do more examples exercises, because there are like there are other cases we need to you know we need to check. Well, of course, I mean, the idea is always the same. From you start from the left, you always start from the left. Whenever you graph any function, you always start from the left. You go from left to right. And when you start from the left, of course, you are at negative infinity, and negative infinity, you have your, I mean, in general, you have your horizontal asymptote, right? So you always start from your graph, you know, very close from the horizontal asymptote. And then, of course, you see if you have like, you check if you have like an x-intercept. The next thing would be an x-intercept or a vertical asymptote, etc. You know.
I have a question.
Yeah. Yeah, please.
For the y-intercept, right?
Mm-hmm.
Is it 0/9?
And 0/9, that would be 0. Yeah.
So 0/9 is 0, right?
Yeah. Yeah.
Okay.
Yeah. Just 0. Yeah. Mm-hmm.
Professor.
Yep.
The graph do have a two zero intercept. We have y-intercept at 0 and 0, and a
Yep.
x-intercept 0. So is it a multiplicity of 0 or 2?
Yeah, I mean, the origin is going to be at the same time an x-intercept and a y-intercept. That's what you're saying, right? The 0, 0, the origin, yes. Yeah. It's at the same time. It's an x-intercept and it's also y-intercept.
So can it be used as a multiplicity? Like
No. Here, there's no. I mean, even 0 is a multiplicity 0. Sorry, multiplicity 1. I mean, you're supposed to cross when you have like an x-intercept, you're supposed to cross your x-axis anyway. Yeah, no, you don't, no need for multiplicity here.
Oh,
All right, guys, I mean, we have like 7 minutes left. So I'm gonna go over this exercise. And as I said, Wednesday, we're gonna do more exercises. So yeah, first, so the vertical asymptote. So we have the vertical asymptote. And so we need to solve the denominator equal to 0. So there will be, so we need to solve, of course, x minus c times x plus c equal to 0. So then either x minus c is 0 or x plus c is 0. So then, of course, then x is positive c or x is negative c. So we got two vertical asymptotes. So vertical asymptote are, so we have the x positive c and the x equal to negative c. All right, so that's for the vertical asymptote. So for the horizontal asymptote, so we need to compare degrees of p and q, degrees of p and q. So then, you know, p is it's this 2x times x minus 2. So we need to distribute, guys, to, you know, to find the degree of p. So when you multiply 2x times x, that will be 2x squared, right? And then 2x times minus 2, that will be minus 4x. So 2x squared minus 4x q, it's x minus 3 times x plus 3. So when you distribute, that's x squared plus the x minus the x, and then minus 9. All right, so then degree of p is 2, degree of q is 2, so they are equal. Q, so there'll be 2. So in this case, so the horizontal asymptote, is, so y equals 2. And so we need to take the ratio of the leading coefficients, right? So the leading coefficient of p, it's 2x squared. So it's the number or the coefficient in front of x squared, it's 2. So here it's supposed to be 2 over, so 2 over, and now for q, the leading coefficient, it's 1, right? It's just x squared, so this is like 1 times x squared. So it's 2 over 1. So that will be equal to 2. So that's my horizontal asymptote. 3, the x-intercept. Yeah, just the x-intercept here, guys. I mean, x-intercept, solve the top equal to 0. So that's the 2x times x minus 2. Yeah, x minus 2 equal to 0. So just be careful here. I mean, you know, your first factor is supposed to be 2x because it's 2x times, right? So so here we have the product of two factors. So first factor would be the 2x, and the second factor is the x minus 2. That's my two factors. So either the first factor is 0, this is my first factor, right? And this is my second factor. So either my first factor is 0, or, so my first factor is 2x, right? Or of course, the x minus 2 is 0. So 2x equal to 0, guys. Of course, you can just divide, you know, get rid of the 2, you can just divide by 2, right? Both sides. So then x and 0 over any non-zero number is 0. So 0 over 2, of course, is just 0. Right? So keep in mind, guys, 0 over any non-zero number is 0. And then, of course, x minus 2, that will be x equal to positive 2. Right? So we have two. So we have two x-intercepts. So x-intercepts are 0. So that'll be 0, 0. That's the origin, right? And then 2, 0. Now, for the y-intercept, I mean, this is kind of different from the previous examples. So the y-intercept, it turns out that the y-intercept actually is also 0, 0. So for the y-intercept, so again, this is just evaluate f of 0. So it's 2x, so that'll be 2 times 0 minus 2, over 0 minus 3 times 0 plus 3, right? Just replace x by 0. Now, the thing is 2 times 0, I mean 2 times 0 times wherever, it's going to be 0. So this thing here at the top is going to be 0, right? Because it's, it's 0 times wherever. So it's going to be 0. Over, and the denominator, it's negative 3 times positive 3, so that's negative 9, actually. But anyway, so 0 over any non-zero number is 0. Okay, so then the y-intercept is just 0. So that would be 0, 0. Okay, so as you can see, my y-intercept is the same as my first x-intercept. All right, in 1 minute, guys, I'm gonna graph the function f. It's gonna be very kind of fast. But anyway, as I said, I'm gonna do more examples on Wednesday. So my vertical asymptote are -3 and +3, I think, right? And then we have a y-intercept. Sorry, my horizontal asymptote is also actually y equals to 2, right? And I have 0, 0. So I'm gonna need 0 here. This is 0, and I'm gonna need a +2. So this is +2, my second x-intercept. So if you graph the vertical asymptote at -3 and +3. This is my vertical asymptote. And then you graph your horizontal asymptote at, so y equals to 2, my horizontal asymptote. And then we have 2 x-intercept, 0, 0, and 2, 0. And my as I said, my y-intercept is going to be the same as my x-intercept. So in 30 seconds, guys. So for the first part of the graph, again, we're going to have like two options, either above or below the horizontal asymptote. But because there is no x-intercept in the below the horizontal asymptote, so the graph has to be above the horizontal asymptote. Okay, it cannot be below because you don't have an x-intercept below the horizontal asymptote, right? And then here, the third, for the second part of the graph, actually, here is kind of tricky because both options, they're gonna be, I mean, you can start from the top here, right? How much time do you have? Okay, I need at least 2 minutes to explain this. All right, you know what, guys? I'm gonna grab this on Wednesday because I need some time to explain. Okay, I'm gonna finish this exercise on Wednesday. Sorry, guys, I went over time again. So I'm gonna stop here, guys. Thank you for listening, and we're gonna discuss this in more details on Wednesday. All right. Take care, everyone, and see you on Wednesday. Thank you for listening.
All right, take care.
Professor?
Yeah, Shakwana, yeah. I'm gonna just stop recording just 1 second.
Okay.
I'm gonna just stop recording. All right.